Welcome to video 9.9b, finding trig ratios. So I've got three examples here. First example, find the ratios in this triangle. So I've got to find sine, cosine, and tangent of angle P, and sine, cosine, and tangent of angle R. I'll do them one at a time. So for angle P, what I'm going to do is I'm going to circle that as my reference angle, and then label. Always opposite the right angle is the hypotenuse. Opposite the reference angle is the opposite, and the other one will be called the adjacent. Okay, you might want to do this in pencil so you can erase and do the other ones. All right, so the sine of P, SOHCAHTOA, opposite over hypotenuse, 15 over 17. Just leave your answers in exact simplified form for these types of problems. Cosine of angle P, I don't have the adjacent, but I happen to know the 8, 15, 17 Pythagorean triple, so this has a side length of 8. If you forgot that, you could have used the Pythagorean theorem, just takes a little bit longer. So adjacent over hypotenuse, 8 over 17. Tangent of P, opposite over adjacent, 15 over 8. Okay, now these talk about angle R. So I will now make angle R be my reference angle. Again, the hypotenuse is always opposite the right angle. That doesn't change. But now this side is the opposite, and this side is the adjacent. So for the sine of angle R, opposite over hypotenuse, 8 over 17. Cosine of angle R, adjacent over hypotenuse, 15 over 17. And tangent of angle R, opposite over adjacent, 8 over 15. Okay, example 2. Now what we're going to try to do is find angles that make these ratios happen. Okay, so slightly different. So, 7 over 24 equals a tangent of, well, I don't even see a 24 there, but I do recall the 7, 24, 25 Pythagorean triple. So again, remember 25 is the largest, so 24 would be there. All right, so if I want 7 over 24 to be the tangent of an angle, that's got to be opposite over adjacent. So I want this to be opposite, and I want this to be adjacent. So I've got to determine which angle will have a side of 7 opposite of it. Oh, angle T. This would be the hypotenuse. This would be the opposite. So angle T makes that happen. All right, I want to find the angle such that the cosine of the angle is 24 over 25. Well, that's going to be adjacent over hypotenuse. So which angle has 24 as the adjacent? Oh, again, if angle T is the reference angle, 24 would be adjacent to it. So once again, it would be angle T. Okay. Third example. If the sine of angle D is 20 over 29, find the tangent of angle D. I'm a visual person, so I'm going to start by drawing a little diagram. Okay, I've got my right angle. We're talking about D. You could put D at either of those acute angles. I'll just choose to make it be there. I'll circle it. That'll be my reference angle, and I'll start labeling. Always opposite the hypotenuse. Opposite the right angle is the hypotenuse. Opposite the angle is the opposite. And the other one is adjacent. All right, so now I've got my picture. Let's fill in numbers. So the opposite would be 20. The hypotenuse would be 29. If I want to find a tangent, I will need to figure out that side there. Okay, there's a couple ways of doing it. One way is knowing a Pythagorean triple, which is called the 20, 21, 29 right triangle, or just use the Pythagorean theorem. Let me call this x for now. So I've got leg squared plus leg squared equals hypotenuse squared. X squared plus 400 equals 841. X squared equals 441. take the square root, x, 441, x equals 21. Okay. So in either case, we found that side. So now the tangent of D, so the tangent of D is going to be opposite over adjacent will be 20 over 21. So there you have it, a few examples using SOHCAHTOA.